My first 6 months working as an engineer were miserable. I felt a mix of emotions: disappointment, confusion, frustration, overwhelmed, despair, agony, loneliness, and anger. Sorry guys, this is probably going to be one of the hardest videos I've made so far, where I simply reflect on my first 6 months working as a mechanical engineer. So yeah, for those of you who don't know me, I graduated from Boston University in the May of 2016, and afterwards I packed my bags and headed to Tsinghua University, located 7,000 miles away from home, and graduated with a master's degree in mechanical engineering in the July of 2018. Immediately afterwards, I started work as a mechanical engineer at Sloan in Boston, Massachusetts, which will be the focus of this video. I'll first talk about my overall experience within the first 6 months, the emotional roller coaster I went through, and the biggest challenges I faced working in industry. Secondly, I'll share the positives and good parts about my job. I'll then wrap up by sharing the biggest differences I noticed between engineering and academia versus industry. So I landed a job as a mechanical engineer 2 at Sloan 1.5 months prior to graduation. I graduated in July and my start date was in August, so I had very limited time to move all the way from Beijing to Boston, find an apartment, buy a car, and get settled in. So as you can imagine, things were a little bit hectic. Sloan designs and manufactures automatic flush valves, faucets, soap dispensers, and hand dryers. And I worked in their electronics division, which encompasses everything from the design, optimization, and manufacture of the PCBs and sensors to the valves. Now, as a naive graduate, I quickly learned that having a bachelor's, master's, or PhD degree doesn't mean much when it comes to understanding all of the bits and pieces needed to run a business successfully and the functions that each department serves within a company. Academic success definitely doesn't equate to success in industry. Many of the things that I know now all seem like common sense, but were all totally foreign to me when I first joined Sloan, and was knowledge that I slowly accumulated over the first 6 months. For example, never in 100 years did I imagine I would have to interact with so many different kinds of people from all walks of life as a mechanical engineer. In my mind, I envisioned myself working with different types of engineers, not project managers, product line managers, global supply chain managers, master data managers, industrial designers, machinists, suppliers, and vendors. Now, first, I want to share a bit about my experience working with these people, starting with the engineers. Believe it or not, I actually learned more talking with these people than doing the purely technical work of my job. In terms of the mechanical engineers working in the electronics division at the time, there was me, 2 mechanical engineering interns, a mechanical engineer 1, 2 senior mechanical engineers, 1 principal engineer, and all of us reported to the chief scientist, which I thought was a really unique title. Typically, you would expect to report to an engineering manager. Our team was pretty small, and I actually prefer that because it allowed me to get to know each team member better and just pick their brains about the company, projects, and anything else I wanted to know. Whereas with a large team, it would probably take a lot longer to get to know everyone or simply learning everyone's names. Of course, we also work closely with the larger team of mechanical engineers based in Chicago at Sloan's headquarters. The electronics that go into Sloan's products are designed, tested, and assembled at their Massachusetts facility, so it makes sense that all of Sloan's electrical, software, and optical engineers work at this location. We collaborated very closely with them on every project to ensure things like PCBs and cables are constrained within a very limited physical space, that they're protected from dust and water, and packaged properly. We also work collectively to make sure that all of the electrical and optical systems integrate seamlessly with the mechanical components components that we designed. There were also 2 to 3 manufacturing engineers who oversaw and managed the assembly lines for each product line in the plant. We worked with them to come up with process flowcharts, optimize designs to reduce cycle time, cost, and assembly steps, and design assembly jigs and checking fixtures. Because we designed a lot of plastic injection molded and casted parts that were produced by suppliers all around the world, we had to work with our internal quality engineers following the production parts approval process to ensure the manufacturing processes of our suppliers could produce parts that are consistently within specifications, free from defects, and that they could meet our annual volumes. Now, working with all of these engineers quickly taught me several things that university failed to teach. Lesson number 1 is not everyone is your friend. There are certain individuals who will make your life and job difficult for various reasons, maybe because of differing intentions or a desire to advance their own career, or maybe they're just psychos. I don't know. But whatever the case may be, you have to learn to accept and know how to deal with these kind of people, which I failed to do early on. There was this principal engineer in our group who was very nosy and felt like he needed to micromanage me and other younger engineers in our group. Lucky for me, my cubicle was right next to his, and oftentimes he would just come over and ask me what I was doing, which project I was working on, and tell me straight up that I was doing X, Y, and Z wrong. This guy even had the balls to tell me that I would get into a lot of trouble for making a mistake, which I actually believed at the time because he was a principal mechanical engineer and I literally thought I was going to get fired. Looking back now, I can't believe how stupid I was for believing him and allowing him to walk all over me like that. Eventually, I shared all of this with a senior engineer that I vibed with, and he told me, "Oh yeah, he treats everyone like that. Just ignore him because he's not your boss." Although his advice was simple, it brought me so much relief and made me realize that he had no business telling me what to do or how to do something, especially with his bad intentions. I later had a chat with my boss, and ever since then, he never stepped foot into my cubicle again. So the moral of the story here is, if you come across someone who's objectively extremely difficult to work with, don't keep it to yourself or think that you're the problem. Be genuine and explain the situation to your boss or a coworker you trust, because as the new kid on the block, you really don't have any idea of what the people in the company are like, whether they have bad personalities or weird tendencies. Communication is key in this situation, and your boss is there to help you, so don't let these kind of people get the best of you. Now, this sort of leads into the second lesson I learned. You can't treat everyone the same. You might be wondering what I mean by this. When joining a company, many engineers prioritize carrying out their job responsibilities perfectly. In my case, that's learning the ins and outs of products, company workflows and jargon, and bringing a product from ideation to mass production, etc. While this is a good mindset to have, I learned that this is not enough or shouldn't be the key focus. Instead, focus on getting to know your coworkers, whether you like or hate them, because these are the people who you will ultimately be working with. A big part of your success and whether you can complete a task boils down to your coworkers and your relationship with them. So try your best to learn their job functions, what they like and don't like to hear, their personalities, tendencies, and most importantly, show that you respect them. When I first joined the company, I approached everyone the same way by directly asking or telling them what I needed from them. Whether it was asking an engineer to check in SOLIDWORKS part files into our PDM vault, or borrowing tools from our technician, or filling out a purchase order and telling our buyer to pay a specific machine shop so that we can get parts made. But this approach is not very smart because everyone is different. I quickly learned that one of my coworkers loved when I small talked about some random topic before asking him to do something, and another coworker was reluctant to talk and just wanted me to cut right to the chase. Some coworkers prefer I schedule a meeting or write an email to talk about something, and others prefer that I just knock on their office door. Now, it might be hard to visualize or gauge how much your job will depend on your coworkers, but trust me, 9 times out of 10, your job will depend on every single person you see in the office, whether it's now or later down the road. Now, one of the best examples I can give is to get a mechanical drawing approved require over 10 different individuals, including 3 different mechanical engineers, my boss, manufacturing, sourcing, quality, marketing, and regulatory to review it. And after all of this is complete, the mechanical engineer has to have the MDM, which is the person who manages all of the company's documents and workflows, to go into the system and close out the drawing. So it was crucial for me to build a good relationship with people at the start, and I felt that hindered my ability to accomplish some things early on in my career. For some people, it comes more naturally, and for others, it requires more effort, and that's okay. The important thing is to identify the significant elements of your job and work on the skills that will help you succeed. Every engineering job will be different, but every job will require you to work with people and on a team. So definitely don't neglect this aspect of your job. Now, when you're completely brand new to a company, there's a certain level of increased stress because you are being bombarded with all kinds of new information and sort of balancing doing the job to the best of your ability and getting to know everyone on a professional level. For me, I felt stressed all the time for the first month or so. I felt like I needed to work around the clock to stay on top of everything, but in actuality, it was totally unnecessary and just myself over-stressing about every little detail. Sometimes it was so bad I had trouble sleeping or breathing at night. Slowly over time, things got a lot better in months 3 and 4 as I became better acquainted with my job and the company. I realized the importance of separating work from my personal life and discovered different ways to manage stress and my emotions. For me, that meant going out for a run in the morning or after work and doing the little things like not checking my email inbox after work. I learned that my physical and mental health is the most valuable thing to me because I can find a job wherever and whenever I want, so it's definitely not worth sacrificing my health for any job. If you quit or your health falls off a cliff, a company isn't going to feel bad or hesitate one bit. What the company is going to do is shrug its shoulders and go find a replacement the next second. So these were some of the biggest challenges that I faced during the first 6 months working as a mechanical engineer. Although the technical aspect of my job was pretty challenging, it was also one of my favorite parts of the job. I learned so much in so little time at Sloan because I got to participate in all stages of a project, which probably wouldn't be the case if I worked at a multinational company on a global 500 list. I was heavily involved at every stage in the product development process, starting with the conceptual design or ideation stage, where I had to work with industrial designers, marketing, and engineers to figure out the aesthetics and ergonomics of the product, how big and what color it would be, what functions it would offer, and how customers would perceive and interact with it. In the next stage is the high level and detailed design of the product. Here I used SOLIDWORKS and Creo to design all of the parts needed to build a proof of concept to demonstrate the feasibility of the design. In this stage, it's up to the mechanical engineer to decide what processes will be used to fabricate the parts. In my case, I used 3D printing, CNC machining, and off-the-shelf components to build multiple variations of the same prototype. Each of the prototypes were tested for performance, ergonomics, human product interaction, and might be presented to management and customers to get their feedback. Iterations and design changes would be continuously implemented based on what people are saying, as well as test and simulation results until all parties and stakeholders are satisfied. This stage is probably the most demanding and critical for mechanical engineers because you want to get everything right and not have to make big changes later on that could significantly delay a project. It's hard to put into words how much effort, time, skills, and tools were required to get the design to a point so that it was production ready. To make parts, suppliers typically require a technical drawing of each individual part with critical dimensions, tolerances, materials, surface finishes called out, as well as annual volume so that they can quote a price. A lot of our suppliers were Chinese, so there was naturally a language barrier that existed, and being one of the very few engineers in our company who could speak fluent Chinese, I had the added responsibility of translating a lot of the meetings between our suppliers and our global supply chain manager, who manages all of the suppliers we work with and negotiates pricing with them. We of course also had to apply design for manufacture and assembly, or DFMA principles, to ensure every part could be mass-produced for various manufacturing processes like injection molding and casting, and work with suppliers in our quality department to rectify any part features that were out of spec or any part defects that we observed during the incoming quality inspection of the first batch of parts that our supplier sent us. Aside from CAD and simulations, we also had to perform DOEs, gauge R&R, FMEA, tolerance stack-up analysis, and leverage various statistical methods to optimize and de-risk the overall design of our products. This process was definitely slow and overwhelming at times, but in the end, it was totally worth it to see the design come to fruition. Now, one thing that helped me master these essential technical skills needed to succeed in industry as a mechanical engineer is Brilliant, the sponsor of today's video. It's the best platform offering thousands of hands-on lessons in math, programming, physics, data analysis, and AI. Brilliant breaks down problems into easy to understand thinking blocks. Their lessons contain a bunch of interactive quizzes and animations that allow you to test out new concepts. This method is proven to be 6 times more effective than traditional lecture-based learning. Brilliant's content is crafted by professors, researchers, and professionals from places like MIT, Caltech, Microsoft, and Google, so you will be learning from the best. Brilliant champions active learning over memorization, so you build critical thinking skills and become a better thinker along the way. Brilliant also fosters a habit of daily learning that's essential for personal and professional growth. Learning will always be a blast with Brilliant's engaging bite-sized lessons that easily fit into your schedule. Vectors is a super useful course that I took on Brilliant that teaches you the core principles of vector mathematics, including scaling, transformation, polar coordinates, and dot products used to describe motion and orientation in space. To try everything Brilliant has to offer free for a full 30 days, visit brilliant.org/engineeringgonewild or check out the link in the description below. You'll also get 20% off an annual premium subscription. Now remember, the technical work that I just described is only part of my job. If I had to break down the different types of work that I do, 40% of the work is purely technical and 60% is non-technical. The technical work includes designing, analyzing, optimizing, and testing products. The non-technical work includes attending meetings, which for all intents and purposes, I won't include as technical work, as well as replying to emails, chatting with coworkers, writing reports, crafting gate review presentations, ordering parts, generating part and drawing numbers, and completing engineering change notices. Most of these non-technical tasks are the less enjoyable parts of my job, but nevertheless still important. Every engineering job, or every corporate white-collar job for that matter, will more or less come with these non-technical tasks and responsibilities. I strongly believe that there's no perfect job, and overall I had a very positive experience working at Sloan. My favorite part about Sloan was actually the employee diversity. Just in my team alone, there were engineers from Nepal, Romania, the UK, and my boss was from Germany. The manufacturing director was Indian, the director of engineering was Chinese, and the assemblers and technicians on the shop floor came from over 20 countries. So, after working at Sloan for the first 6 months, what were the biggest differences I noticed between being a mechanical engineering student in university versus being a professional mechanical engineer in industry? Well, the biggest difference for me was the people. In school, it's simple. You just work with students and professors who are pretty laid back and there to help you. It's easier to build personal relationships. But don't expect any of this once you step foot in industry, because completing tasks and achieving goals is the primary focus rather than building personal relationships. Now, this doesn't mean that professional relationships can't be personal or respectful, but it's important to be mindful that most people aren't there to build genuine friendships. In terms of collaboration and teamwork, in school you work on assignments and projects either individually or in groups of 3 to 5 people with limited collaboration beyond your immediate classmates. Whereas in industry, like we mentioned earlier, you work in cross cross-functional, multidisciplinary teams spanning engineering, marketing, sourcing, finance, regulatory, quality, and manufacturing that can involve complex interactions and require some form of strategy. Next, transitioning from an academic setting to industry, at least for me, required getting accustomed to corporate lingo and project management methodologies. Corporate lingo varies by company, but in general, it includes a lot of acronyms and terms that you probably never come across in school, like KPIs, KOL, CT, PTO, ROI, ECN, deliverables, action items, etc. Learning these should be relatively straightforward, but you definitely won't memorize all of them overnight. What helped me learn these faster was simply listening carefully to people chat in meetings and jotting down any words and acronyms that were new to me and simply going back and Googling their definitions. Now, engineering projects in industry have a lot more layers, constraints, and constantly evolving requirements compared to school projects that are one-dimensional and static. That's why each company has its own project management methodology like Agile or Waterfall and hires project managers to coordinate and execute a project, identifying risks, managing resources, and ensuring every DRI, which is another corporate term, stays on track. It's important to understand our company's project management workflow, key milestones, and what we and others need to accomplish in each stage to complete the final project deliverables. Lastly, in school, no documentation is required. You submit a lab report or project and you're done. However, mechanical engineers in industry need to document and report everything they create, including CAD files, drawings, installation instructions, test reports, and more. Companies will have their own product data management system to track revisions, manage engineering change orders, and archive files. For me, I hated this aspect of the job because it can be annoying and excruciating work if a company has developed workflows that are nearly impossible to navigate due to bugs and kinks in the system, and getting anything approved like drawings is like pulling teeth. Alright guys, that's it for today. I hope my experience can help you prepare for some things in industry that universities neglect to teach and avoid the emotional roller coaster that I went through in my first 6 months as an engineer. As always, thank you so much for watching, and if you enjoyed this video, be sure to smash the subscribe button and check out my video here where I talk about the one skill that changed my life as a mechanical engineer, and I'll see you in the next one. Peace.